February 1944, Western Belgium. Allied intelligence teams tracked over Quatre-Vingts German Panzer units across their maps. They called them Tiger Eye tanks. Each carried the infamous Quatre-Vingts 2mm cannon. That morning, American analysts calculated a grim equation. If German armor broke through at Ardennes, Allied casualties would exceed Kinds 000 per week. Nazi engineers at Krupp had predicted the Tiger's frontal armor would make it invulnerable. They believed sheer protection alone guaranteed battlefield dominance, yet by nightfall of March 16, 1944, 74% of engaged Tigers had been destroyed. The highest kill ratio ever recorded against Hitler's premier tank, the key lay in a new tank destroyer, the M18 Hellcat, and the individual crews who pursued Tigers with little more than speed and audacity, often outmaneuvered at ranges exceeding 2,000 yards. One tactic defied every rule of armoured warfare, striking from angles no conventional tank could achieve. In the span of weeks, a machine built for hit and run became the instrument of offensive defence. This number, 74%, would alter the course of the ground war. December 16, 1943, Bastogne, Belgium, at 05 and 0 hours, forward observers at the Dixt Armoured Division spotted an unfamiliar silhouette approaching through the morning fog. It produced a distinctive low rumble unlike any Allied tank engine they had heard before. A trail of crushed trees and fences marked its path through the pre-dawn darkness. Moments later, the first Tiger Eye heavy tank fired on an American roadblock near Neuville. 3 M18 Sherman tanks were destroyed instantly. 17 more American crewmen died from direct hits. The impact left smouldering wrecks blocking the crucial supply road. The battalion situation report number 40 and landed on General Patton's desk within hours. The document's language remained clinical, but the implications were unmistakable. A new form of heavy tank confirmed. Estimated frontal armor cent. Intelligence estimates effective range of main gun. Exceeds 500 yards. Intelligence analysts at SHAEF headquarters had intercepted German radio traffic for weeks. The codename Königstiger appeared repeatedly. Now they understood what it meant. American intelligence estimated Germany could manufacture 45 Tiger tanks per month if production facilities remained untouched by bombing. Each tank carried an 88mm cannon capable of penetrating any Allied armour at range beyond 2,000 yards. The math was simple and terrifying. If deployment matched production capacity, the Ardennes sector would face 3 Tiger battalions within 6 weeks. General Eisenhower ordered General Bradley to provide an immediate countermeasure. No German armour must reach the Allied supply depots. Yet early engagement data from the Doings Armoured Division showed only a 9% success rate in the first 48 hours. Standard M18 Sherman tanks, even those equipped with the improved 66mm gun, struggled against the Tiger's frontal armour. Fire control systems calibrated for Panzer cars with 75mm guns failed to penetrate the new threat. Gunners calculated lead angles for targets they expected to destroy at Whitsense yards, only to watch their shells bounce harmlessly off Tiger frontal plates. The Sherman's maximum effective penetration fell short of the Tiger's armour by more than 40mm at combat range. Gunners watched helplessly as Allied tanks burned, one after another. The Maybach Igel 230 engine produced 700 horsepower through a complex drivetrain that gave the Tiger exceptional torque, creating the characteristic deep rumble that gave the weapon its fearsome reputation. The Tiger's mechanical simplicity shocked Allied engineers. Interleaved road wheels provided remarkable cross-country mobility, despite the tank's 56-ton weight. Germany had created a breakthrough weapon using straightforward industrial methods. Captured technical manuals revealed the Tiger's guidance system's elegance. A Turmzielfernrohr, 9B gunner sight maintained accuracy. A hydraulic turret traverse allowed smooth target tracking. An advanced rangefinder calculated distance with remarkable precision. When the gunner lined up his shot, the 88 mm cannon delivered a Dix, 2 kg shell at 8 cm per second. Impact followed within seconds. No elaborate electronics, no complex fire control. A heavy tank programmed for one purpose: kill American armor at extreme range. The shock was immediate and profound. A single weapon had outfought America's entire armored force structure. Standard M4 Shermans, powered by 400 horsepower Continental Ardennes, 175 engines, could barely maneuver against the Tiger's superior range. M6 tank destroyer, despite their turreted 3-inch guns, lacked the penetration needed at realistic combat distances. M26 Pershings, though promising, remained months away from deployment. By the end of that first week, 38 Allied tanks had been destroyed across the Ardennes sector. Artillery batteries claimed 3 confirmed Tiger kills. Armoured divisions recorded 0 penetrations credited to Sherman 75 mm guns. Forward Observer tracked each Tiger sighting with grim precision. 342 American tankers would die before the campaign ended. Except 880 tons more would suffer injuries. The weapon's psychological impact exceeded its physical destruction. GIs, who had endured Normandy, now faced an enemy that struck from extreme range, immune to frontal assault, unstoppable by conventional tanks. In underground operations centres across Belgium, intelligence officers recognised the magnitude of the problem. Armour protection. The Tiger was too heavily armoured for guns, too well positioned for flanking attacks, and too tactically sound for conventional counters. America needed a tank destroyer capable of sustained 50 mil/h performance across broken terrain. They needed it immediately, and they needed it in numbers. None had penetrated Tiger frontal armour in 7 days. December 20, 1943. 1st Army HQ, Belgium. In the underground command post beneath Saint-Vith, General Ridgway stood before a wall-sized map of the Ardennes forest. Red pins marked Tiger sightings. Blue lines represented proposed defence belts. Ridgway had commanded defensive operations since 1942. He understood that the current system had failed completely. Tank destroyer command needed a new architecture built around speed, not firepower. Ridgway signed the order reorganising all northeastern defence under Operation Cobra. The new plan divided Belgium into 3 concentric defensive belts. First, artillery batteries positioned along likely advance routes, primarily in the Ardennes. These batteries would engage Tigers immediately upon detection, before they closed with American armour. Second, a mobile interception zone stretching from the front lines to supply depots. Fast tank destroyers would patrol assigned sectors, vectored by forward observers to intercept Tigers that penetrated the artillery belt. Third, minefields and anti-tank ditches protecting critical road junctions. These created final obstacles against breakthrough attempts. The First Army's daily operations summary for December 23 recorded the system's teething problems. Of 32 Tigers plotted, 7 engaged, 3 destroyed. The mathematics indicated catastrophic failure. Engagement rate 53%. Kill rate among engagements 8%. Overall effectiveness 9%. If every Tiger deployed reached target probability, American armour faced systematic annihilation within weeks. Tank performance data exposed the core problem. M4 Shermans achieved 24 mil/h on roads, but only 15 mil/h cross-country. The Continental engine performed adequately on flat terrain, but provided minimal power on slopes or in mud. Closing speed against a Tiger positioned at 2,000 yards measured only 10 mil/h, requiring nearly 8 minutes to close from detection to effective firing range. By then, the Tiger had often fired 3 or 4 aimed shots, each capable of destroying a Sherman. The M6 Wolverine tank destroyers carried 3-inch guns and open-topped turrets. Maximum speed reached 30 mil/h on roads. Cross-country performance dropped to 20 mil/h. Against the Tiger, Wolverines had marginally better guns than Shermans, but remained undergunned and under-armoured. 26 Pershing heavy tanks, though promising with their 90mm guns and improved armor, remained in development. First production units wouldn't reach the front until February 1944 at earliest, at General Motors testing facilities. Engineers ran field trials against mock Tiger specifications. They evaluated every available armored vehicle in the American inventory: Shermans, Wolverines, prototype Pershings. One machine emerged with decisive performance margins: the new M18 Hellcat tank destroyer. Performance figures from Aberdeen Proving Ground trials showed 55 miles per heure on roads, 45 miles per heure cross-country. Powered by the 400 horsepower Continental 975 radial aircraft engine, the Hellcat represented American engineering focused on a single principle: speed kills. Before we jump back in, tell us where you're tuning in from, and if this story touched you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Its lightweight torsion bar suspension provided exceptional cross-country mobility. Christie-derived running gear allowed maintenance in the field without specialized equipment. Rate of traverse exceeded every other Allied armored vehicle. Acceleration allowed flanking maneuvers with 35 miles per heure overtake speed. The Hellcat could reach a firing position, deliver a lethal round, and clear the area before a Tiger's turret completed its rotation. Tank Destroyer Command's Operational Analysis Division calculated engagement probabilities. An Quatre Sherman detected at 2,000 yards by a Tiger had 8% probability of successful engagement. A Hellcat under identical conditions achieved a 53% probability. The difference lay entirely in speed and maneuverability at combat range. The Hellcat could advance, flank, engage, and withdraw within a single 20-minute combat window. Shermans advancing directly into Tiger fire zones simply died. On December 24, Ridgway issued an emergency deployment order. Every available Hellcat would be transferred immediately to Operation Cobra units. Production priority shifted from standard tank destroyers to high-speed variants. Ammunition loads doubled. Radio equipment upgraded. Gun cameras became mandatory. The Army needed data on engagement geometry, ammunition expenditure, and kill confirmation. This was a new kind of tank warfare: speed against armor, maneuver against firepower. The first true asymmetric armor campaign. Only 25 Hellcat units existed in operational condition on December 24. Buick Motor Division had delivered fewer than 80 since production began in mid-1943. Most equipped training units supporting the build-up in England. Ridgway's order stripped those units, reassigning vehicles to newly formed anti-Tiger battalions at forward positions in the Ardennes. 612 Tank Destroyer Battalion at Bastogne. 603 Tank Destroyer Battalion, staffed by newly arrived replacements at the same location. 705 Tank Destroyer Battalion at Saint-Vith, as reserves rotated in. Within 72 hours, the first Hellcat crew scored a confirmed Tiger kill. Proof that speed had an operational solution, but could 25 Hellcats stop 135 Tigers per quarter? December 26, 1943, Bastogne, Belgium. Maintenance crews showed fuel tallies on status boards as 612 and 603. Tank destroyer battalions accepted their first operational Hellcats. The staging area sat less than 20 miles from the front lines, positioned directly beneath the Tiger approach corridors. Crews could deploy, reach battle positions, and engage targets within minutes of spotting reports. Time and distance geometry favoured the defenders here, in ways impossible at rear areas. Captain Michael Reynolds arrived with the first platoon of Hellcats transferred from the 6th Armoured Division. Reynolds had commanded M18 in North Africa, hunting Panzer, IVs across the desert. He understood conventional tank warfare, but this mission required different skills. Pure speed, precise flanking maneuvers, split-second timing. A tank crew learned to advance, fire, and consolidate positions. The Hellcat crew had to race across open terrain at 50 miles per heure, find concealment, fire from ambush at a Tiger's vulnerable side armor, and escape at maximum speed before German gunners could respond. Reynolds logged the Hellcat's vital statistics in his personal notebook that evening. Maximum speed 55 miles par heure on roads. Combat speed cross-country 35-40 miles par heure, depending on terrain and ground conditions. Climb rate excellent on 30-degree slopes, acceptable on 45-degree. Service radius limited by fuel to approximately 100 miles of cross-country travel before reserves reached minimum recovery level. Armament consists of one 76 mm Menon gun mounted in a power-traversed open turret. Each vehicle carries 45 rounds. Standard armor penetration 100 mm return, 000 yards. Theoretical effective range 200 yards. In practice, combat engagements occurred at 500 yards due to terrain constraints. Pilots learned quickly that ammunition selection determined mission success. Standard AP rounds worked against Panzer IVs, but struggled against Tiger frontal armor. HVAP tungsten core rounds, though limited in supply, could penetrate Tiger side armor reliably at 500 yards. Empty guns meant returning to base while Tigers advanced unchallenged. The Continental Renault 975 aircraft-derived radial engine represented American industrial might applied with pragmatic efficiency. 9 cylinders arranged in a radial pattern, air-cooled design eliminating complex water cooling systems, aircraft-grade components, and ease of maintenance. At 400 horsepower, the engine produced less raw power than German designs, but weighed significantly less, creating an exceptional power-to-weight ratio. Hellcats carried only 25 mm of frontal armor compared to the Tiger's 100 mm. This created a 10 ton weight advantage that translated directly into mobility. The engineering philosophy could be summarized simply: don't get hit. Hellcats weren't designed to absorb punishment. They were designed to avoid it altogether. Each Hellcat required 8 dedicated maintenance personnel: mechanics, gunners, radio operators, and drivers. After every engagement, ground crews conducted a 60-minute inspection covering engine oil levels, transmission integrity, suspension components, ammunition feed mechanisms, and radio crystals. 8 hours of maintenance labor per operational day became the standard ratio. Crews noticed immediately the difference between MDIX Wolverines and Hellcat handling. Both carried similar guns, both had open turrets, but the Hellcat's lightweight chassis transformed tank destroyer operations. Control response at high speed remained predictable and positive. The Wolverine required careful management when traversing broken ground above 25 miles par heure. Suspension bottomed out. Tracks threw in tight turns. Gunners struggled to maintain aim. The Hellcat's torsion bar suspension solved these problems elegantly. Independent wheel stations absorbed impact separately, maintaining ground contact across uneven terrain. A Hellcat could maintain 35 miles par heure across plowed fields, railroad crossings, and shallow streams, while gunners kept weapons on target. This characteristic proved decisive against Tigers. Engagement geometry required rapid flanking maneuvers. Forward observers spotted Tigers from camouflaged positions. Radio operators relayed coordinates to Hellcat platoons. Commanders plotted approach routes that minimized exposure. They closed using terrain features for concealment. The Tiger, for all its armor and firepower, suffered from limited situational awareness. Its commander managed a 5-man crew inside a cramped fighting compartment. Visibility was restricted to periscopes and the commander's cupola. A Hellcat approaching at 45 miles par heure from an unexpected direction could close from 2,000 yards to firing position in under 2 minutes. The Tiger turret traversed at 6 degrees per second, requiring 30 seconds for a complete rotation. A Hellcat driver covering ground at 45 miles par heure moved 66 feet per second. During a 30-second Tiger turret rotation, the Hellcat travelled a 980 feet, over 650 yards. By the time the German commander spotted, identified, and traversed, the Hellcat had reached firing position against vulnerable side armor. Reynolds wrote in his notebook after the first week, At last, a machine with the agility to outfight these monsters. The Wolverine is a sledgehammer, the Hellcat is a rapier. Within 48 hours of arriving at Bastogne, Lieutenant Carl Morrison recorded the type's first confirmed Tiger kill. The gun camera film showed the engagement sequence: detection, approach route, flanking maneuver, firing position, cannon fire, penetration. Morrison fired 3 rounds, approximately 8 seconds of combat exposure. The Tiger's ammunition rack detonated. The German tank disintegrated in a catastrophic explosion. No American casualties, one less threat advancing toward Allied lines. The speed problem had an operational solution. Now Tank Destroyer Command needed to scale that solution from 25 vehicles to 250. Production, logistics, training, tactics all had to accelerate at the same pace as the Hellcats themselves. December 27 through 31, 1943, Ardennes forest and Belgian countryside. The Hellcat's first recorded kill came during a routine patrol. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Lieutenant Carl Morrison of the 602 Tank Destroyer Battalion deployed at 07:30 hours on forward observer warning. Radio operators vectored him toward contact reported near Houffalize. Morrison's platoon of 3 Hellcats moved at 40 miles per hour across frozen farmland, maintaining 50-yard spacing between vehicles. The Continental engine's distinctive roar deepened as drivers pushed throttles forward. The geometry lesson was simple. A Tiger at 0 miles per hour versus a Hellcat at 40 miles per hour created a closing speed of 40 miles per hour, 520 feet per minute. To close from 2,000 yards to 800 yards firing position required approximately 2 minutes, but intelligent routing increased survivability. At 20 degrees off-axis, the Hellcat approached obliquely. Gun camera film spooled through analyst projectors at 1st Army headquarters within hours of Morrison's return. Frame-by-frame analysis revealed intercept geometry, flanking angle, burst duration, and kill mechanism. The Tiger appeared partially concealed by hedgerows at 000 yards. Morrison fired the first round, standard AP, approximately 1 second of exposure time. The 76 mm shell arsed toward the target, impacting the Tiger's right track assembly. Mobility kill achieved. The Tiger's movement halted, but its turret remained operational, its weapon unchanged. The 428 mm cannon traversed, searching for targets. Morrison maneuvered to the Tiger's right flank, using terrain depressions for concealment. The second shot struck the Tiger's side armor at a 65-degree angle. Penetration visible on film. The third round entered the penetration point, reaching the ammunition storage. The Tiger's turret separated from the hull in a catastrophic detonation. 43 combat rounds remained in the Hellcat. Morrison checked his vehicle. No damage. Engine temperature normal. Transmission intact. Ammunition feed systems operational. Total ammunition expended. 3 rounds from 45 available. Approximately 70% of total load. This figure caught the attention of operational research analysts. If 3 rounds per kill represented the mean, each Hellcat could theoretically destroy Quine's Tigers per full ammunition load. But reality proved messier. Combat variables target aspect, range, crew skill, ammunition type, weather conditions created wide variation. Some crews needed 12 rounds per kill. Others achieved kills with a single perfect shot. Tank Destroyer Command issued Operational Research Section Report 8/44 on January 2000. The document analyzed all Tiger engagements to date by Shermans, Wolverines, and Hellcats. Statistical findings proved decisive. Probability of kill increased 5-fold when tank destroyers approached from flanking positions at angles exceeding 45 degrees from the Tiger's frontal arc. Frontal assaults, common against Panzer Kurz, proved suicidal. The Tigers sent mm frontal armor defeated even 90 mm rounds at most combat range. Side attacks required extreme maneuverability but increased survival odds dramatically. The Tigers' side armor measured only 80 mm, vulnerable to 76 mm HVAP rounds at 500 yards. The report recommended standardized attack geometry, intercept from flanking position, approach using terrain for concealment, close to 500 yards, fire from defilade positions, observe impacts, correct aim, fire again. Maximum engagement duration 15 seconds to prevent German counter-targeting. Break contact immediately after observing penetration or immobilization. Minimum separation distance 500 yards to avoid 88 mm counterfire. Early doctrine had emphasized volume of fire. Tank tactics since 1942 assumed that overwhelming a target with multiple units guaranteed kills. Hellcat crews initially attacked in platoons, 3 vehicles firing simultaneously at single targets. This approach produced kills, but created unnecessary risk. Multiple Hellcats in close proximity made larger targets. A Tiger that survived initial shots could engage stationary Hellcats with devastating effect. The open turret design, chosen for weight reduction and visibility, left crews vulnerable to 88 mm airburst rounds. A Tiger gunner who bracketed a Hellcat position could fire high explosive shells that detonated above the open turret, sending fragmentation downward into the crew compartment. The operational research section recommended dispersed precision over concentrated volume. Single Hellcats approached from multiple angles, short engagements, immediate relocation after firing, gun harmonization set for 500 yards optimal range. This technique tripled crew survival rates. Average casualties per engagement dropped from 2 to 0. Within 2 weeks as crews adopted the new doctrine. One Hellcat with 45 rounds could now theoretically destroy multiple Tigers in a single operational period if coordination permitted multiple engagements. But fuel endurance remained the constraining factor. 10 miles at combat power. The Continental engine consumed 5 gallons per mile at high speed. Total fuel capacity 165 gallons in standard tanks. Combat radius calculation: 20 miles outbound transit, 20 miles combat patrol, 20 miles return transit. This left approximately 40 miles of fuel reserve, the minimum required by Tank Destroyer Command safety regulations. In practice, crews stretched patrols to 120 or 130 miles, returning with fuel gauge hovering near empty. By December 31st, Hellcats had been credited with 28 Tiger kills. Other armoured vehicles, Shermans, Wolverines, Pershings, accounted for 19 additional kills. Hellcats represented less than 8% of American armoured strength assigned to Operation Cobra, yet achieved 60% of confirmed kills. The correlation was undeniable. Speed equaled success. Maneuver equaled survival. The Army calculated that if Hellcats could triple their kill rate through improved tactics and crew efficiency, America could achieve operational parity against Tiger deployments within 30 days. The math showed one problem clearly. They needed the speed. They needed accuracy. But most of all, they needed more Hellcats. January 2001 through 1944, Bastogne and Luxembourg fuel convoy arrived daily at forward positions in the Ardennes. 5,000 gallon tanker trucks travelled from coastal depot through snow-covered roads, navigating frozen terrain and German artillery to deliver high-octane gasoline. Hellcat consumed 5 gallons per mile at combat speed. A 15-vehicle battalion operated 30 sorties per day, 2 sorties per vehicle. Total daily fuel requirement: 200 gallons. Weekly: 400 gallons. Monthly: 600 gallons for one battalion. Tank Destroyer Command operated 3 Hellcat battalions at peak strength by early January. Combined monthly fuel demand: 352 800 gallons. The Army expanded forward fuel storage from 40 000 gallons in late December to 300, 000 gallons by February. Underground tanks, dispersed dumps, camouflaged reserves. German reconnaissance aircraft photographed Ardennes depot regularly. Luftwaffe intelligence identified fuel storage as critical infrastructure. Tiger units occasionally prioritized supply dumps over forward positions to disrupt defensive operations. Fuel logistics represented only one element of the supply chain. The Continental Engine's aircraft heritage created spare part demands that exceeded any previous American armored vehicle. Ignition systems required replacement after cent hours. Radial cylinder sleeves needed replacement every 2 cents hours. Spark plugs lasted 40 hours under combat conditions, high RPM, maximum continuous power, emergency field settings. Each Hellcat needed a complete engine change every 3 cents operational hours, with battalion vehicles averaging 30 operational hours per week. Engine changes occurred bi-weekly. Maintenance crews worked 18-hour shifts. A single Hellcat required 8 maintenance man-hours for every operational hour. Standard inspection after each mission, 60 minutes. Weekly inspection, 6 hours. Monthly inspection, 30 hours. Engine change, 20 hours with a full crew. Battalion maintenance officers managed detailed schedules tracking vehicle hours, engine hours, component hours, and scheduled maintenance. A vehicle became deadline in Army terminology if any critical inspection came due. Battalion commanders balanced operational requirements against maintenance windows, pushed too hard and the vehicles broke. Rest too long and Tigers penetrated unchallenged. The math created a brutal calculus. 25 Hellcats operating 2 sorties per day generated 50 sorties. Each sortie averaged 90 minutes. Total operational hours per day, 75 hours. Battalion maintenance officer records showed the 6 cent dose ND tank destroyer battalion employed 2 cent 80 support personnel, mechanics, ammunition handlers, radio operators, intelligence analysts, administrative staff. They worked 12-hour shifts in 2 overlapping rotations. Morning shift, 0600 to 1800 hours. Evening shift, 1800 to 0600 hours. Overlap periods 0600 to 0800 and 1800 to 2000 allowed crew briefings and handovers. Typical vehicle turnaround proceeded like this. Hellcat returns from mission. Ground crew directs vehicle to maintenance area. Mechanics begin refueling immediately. 165 gallons pumped through hand-operated pumps. Ammunition handlers reload 76 mm shells. 45 rounds distributed into ready racks. Radio operators check frequencies and battery levels. Instrument technicians verify gun camera film and sight calibration. Mechanics inspect suspension components and track tension. The entire process, refuel, rearm, inspect, required 60 minutes with a full crew. Less than 30 minutes in emergency deployments demanded faster turnaround. Vehicle availability rates determined battalion effectiveness. Tank Destroyer Command required 75% availability for operational units. 19 of 25 vehicles serviceable at any time. Hellcat battalions initially struggled to maintain 65% due to transmission reliability problems. Continental engines developed oil leaks, ignition failures, and carburetor issues at rates higher than tank engines. Typical abort rate, set % of missions. A crew deployed on forward observer warning, reached combat position, then discovered engine trouble and returned to base. Wasted fuel, wasted time. A Tiger advanced unchallenged. Buick Motor Division and Continental recognized the problem. Engineering teams deployed to forward battalions. They analyzed maintenance logs, interviewed crews and mechanics, and identified failure modes. Oil leaks traced to gasket quality. Ignition failures linked to moisture in electrical systems. Carburetor issues resulted from fuel quality variations. Fixes rolled out incrementally. Improved gaskets. Sealed ignition systems. Modified carburetors rated for wider fuel variations. By January, abort rates dropped to 3%. Availability climbed toward 80%. Logistics data revealed an unexpected correlation. Battalions with higher maintenance man-hours per operational hour achieved higher kill rates, not because better maintained vehicles moved faster. All Hellcats shared identical performance, but because reliability enabled more engagements. A vehicle that remained serviceable completed more missions. A crew who trusted their equipment pressed attacks more aggressively. Confidence derived from engineering. Battalion records for early January showed measurable improvement. 25 Hellcats, fewer than 1/10 of all vehicles assigned to Operation Cobra. Destroyed it up with these 270 Tiger tanks, 58% of all credited kills. The remaining 225 vehicles, Shermans Wolverines, towed anti-tank guns, accounted for 128 kills combined. One Hellcat equaled roughly 4 Shermans in Tiger engagement effectiveness. The difference was speed. Sustained, reliable, maintainable speed. Early January tallies crystallized the logistics paradox. More Hellcats multiplied effectiveness non-linearly. 10 Hellcats did not achieve twice the kills of 5 Hellcats. They achieved 3 times the kills because patrol coverage improved, response times decreased, and multiple vehicles could engage Tiger formations simultaneously, but only if logistics supported operations. Fuel, spare parts, ammunition, maintenance crews. The industrial supply chain determined frontline success as much as crew skill or vehicle performance. America was learning that speed alone solved nothing. Sustained speed, maintained, fueled, armed, and reliably deployed won wars. January 8 through 12, 1944, over Luxembourg and eastern Belgium. Forward observers sat at radio sets plotting Tiger movements across map overlays. The system worked like this. Observation posts detected tanks crossing open terrain. Range, bearing, estimated strength, and movement fed into calculation tables at battalion command posts. Controllers assigned Hellcats to intercepts based on geometry, which vehicle could reach which target quickest. Voice radio vectored crews toward contacts. Porcupine 12 heavy armor, bearing 270 15 miles, moving south. Porcupine identified the observation post. 270 indicated westerly movement directly toward American positions. 15 miles gave the crew time to calculate intercept geometry. A Hellcat at 40 miles par heure closed 1 mile every 90 seconds. Intercept point approximately 22. 5 miles from the crew's current position. Mental arithmetic became instinctive. Experienced commanders calculated closure rates automatically, adjusting routes and speeds to arrive at firing position with optimal engagement angles. Too direct? Expose yourself to frontal armor and 4.8 mm fire. Too oblique? Fail to close at all. The sweet spot? 60-degree approach angle, closing from 2,000 yards to 800 yards in 2 minutes, leaving time for aim correction and 3 quick shots. Gun harmonization directly affected hit probability. Hellcat armament consisted of one 66 mm Monaon gun. Gunners adjusted the sight by zeroing against known distance targets. Standard harmonization set the gun to pinpoint accuracy at 800 yards, the point where the ballistic arc provided maximum penetration against side armor. Inside 800 yards, rounds impacted above the aim point. Beyond 800 yards, rounds fell below. Tank Destroyer Command issued revised gunnery doctrine after analyzing gun camera film from the first 2 weeks of Hellcat operations. The new standard: open fire at 000 yards with a single ranging shot. Observe impact, correct, aim, fire again at 800 yards, observe impact, final shot at 750 yards, sustained fire until penetration observed or target destroyed. Maximum total exposure 15 seconds to prevent German counter-targeting. This technique proved dramatically more effective than earlier methods. Average ammunition expenditure per kill dropped from 8 rounds to 3 rounds within 2 weeks. Statistical analysis showed a clear correlation. Crews who fired aimed shots under 15 seconds of exposure achieved kills with minimal ammunition. Crews who remained stationary for extended periods 30 seconds or more often became casualties, victims of the Tiger's superior fire control. The Operational Research Division published Report 11/44 on January 14th. Key finding: interception efficiency per Hellcat sortie now approximately 0.64. The predicted upper bound had been 0. In plain language, 1 Hellcat sortie now resulted in 0.64 Tiger kills on average. Initial projections had estimated 0.20, less than 1/3 current performance. The improvement derived from refined tactics, better ammunition selection, and superior engagement procedures. Crews discovered another advantage. The Hellcat's lightweight suspension allowed precision movement at high speed. A Tiger advancing at 15 miles per hour appeared relatively stationary to a properly positioned Hellcat gunner. The crew established an oblique firing position, matching the Tiger's movement vector but at an angle, then gently applied throttle to maintain perfect tracking. Gunner signal, cannon fire, impact, penetration. The entire engagement resembled target practice more than combat. No wild maneuvers by the target, no infantry support, just geometry and precision. But precision required calmness under pressure. A Tiger carried between 80 and 82 main gun rounds of 88 mm ammunition. Premature detection killed Hellcat crews. Several M18 crews died when they engaged too directly and received 88 mm rounds through their open turrets. The shell penetrated the thin frontal armor. The crew died instantly. No armor protection, no reactive plates. Death came in milliseconds. Hellcat crews learned to respect minimum exposure time, 15 seconds maximum, immediate withdrawal after observing hits, never engage from the same position twice, never challenge a Tiger frontally unless absolutely necessary. Forward observer vectoring improved as controllers gained experience. Initial vectors often placed Hellcats several miles off target. The crew had to visually search while closing, head outside the turret, scanning for a 56-ton behemoth somehow invisible among trees, buildings, or terrain features. By early January, vectors improved to within half a mile. Controllers called the range countdown. 3 miles, 2 miles, 1 mile should have visual. Crews who trusted their controllers achieved higher kill rates. They maintained proper route geometry, speed, and timing until visual acquisition. Crews who ignored vectors and searched independently often missed targets entirely, wasting patrol time. The system worked when all elements coordinated: forward observation, controller calculation, radio discipline, crew compliance. The data suggested a broader truth. Hellcat performance exceeded expectations, not because the vehicle was faster than predicted. Engineers knew exactly how fast it would drive, but because handling qualities enabled precision. A Sherman crew fought difficult terrain at 25 miles per hour. They aimed approximately, fired multiple rounds, and hoped for penetration. A Hellcat crew maintained 40 miles per hour across identical terrain. They aimed precisely, fired single shots, and achieved kills. Control harmony mattered more than absolute speed. Operational Research Section noted in a supplementary report. The M18 Hellcat demonstrates that controllability at speed multiplies effectiveness exponentially. Raw power without control delivers marginal returns. Control without adequate power delivers zero returns. Optimal combination: the Hellcats achieved state delivers multiplicative returns. In the field near Clairvaux, the theory became practice. Crews engaged Tigers with calm precision, firing 3-round sequences, withdrawing cleanly. Ammunition per kill averaged 3 rounds. Sorties per kill approached unity. 1 kill per sortie. The predicted upper bound had been shattered. Suspension systems and transmission reliability, torsion bars and aircraft engines mattered more than raw armor protection. America was learning that the future of armored warfare belonged to precision, not brute force. January 15 through 22 1944. Bastogne and Houffalize patrol sectors. A combat report landed on Captain Reynolds' desk. The crew's after-action review described a no-fire engagement. Lieutenant James Harrison of the 6th St. Trossard Tank Destroyer Battalion, a Hellcat platoon rotating through Bastogne, had intercepted a Tiger north of Houffalize. Harrison closed to firing range, prepared his gunner, calculated deflection, then decided not to shoot. Instead, he paralleled the Tiger's advance, matching its Kinsmille par heure speed exactly, while maintaining Whitsense yards separation and using a tree line for partial concealment. The Tiger commander, apparently unaware of the Hellcat's presence, continued advancing directly toward a crucial road junction. Harrison maintained course and speed, then deliberately allowed his vehicle to be spotted by revealing its profile momentarily. The Tiger reacted instantly. Its turret traversed. Harrison accelerated to 50 miles par heure, shifting position laterally. The 88mm gun tracked, attempting to acquire the target. Harrison changed direction again, maintaining maximum speed but altering course unpredictably. The Tiger, now fully alerted, stopped to establish a firing position. Its turret rotated, tracking the Hellcat's movement. This removed the Tiger from its planned advance route, delaying its arrival at the critical junction. Harrison continued evasive maneuvers, drawing the Tiger's attention for 18 minutes before breaking contact completely. He returned to base with 45 rounds unfired. The battalion intelligence officer asked the obvious question: "Why didn't you engage when you had optimal position?" Harrison's answer entered official records. "I didn't have HVAP rounds, just standard AP. Against frontal armor at that angle, penetration was unlikely, but I could delay his advance by drawing his attention, forcing him to stop and engage." The road junction remained secure. Mission accomplished without firing a shot. Tank Destroyer Command's technical section investigated immediately. They consulted tacticians at the armoured school, Fort Knox. The explanation was straightforward. The Tiger's tactical doctrine relied on psychological dominance connected to superior firepower. Its commander maintained battle rhythm by advancing methodically to prepared positions, establishing fields of fire, then engaging targets from static positions. But the system had a weakness. The Tiger's 70-ton weight and complex drivetrain created poor acceleration and limited tactical mobility. When a Hellcat's high-speed maneuvers drew the Tiger's attention, the German commander faced a decision: continue the advance or stop to engage the threat. Standard German doctrine prioritized threat elimination before advance. The Tiger stopped, its planned timetable disrupted. The Hellcat, seemingly vulnerable, actually controlled the engagement by manipulating the Tiger's tactical response. The technique required extraordinary skill and nerves. Crews deliberately exposed themselves to the world's most powerful tank gun, then used speed and unpredictability to avoid destruction. Any miscalculation, any slight route error, any unexpected terrain feature meant near certain death. The 88mm round would tear through the Hellcat's thin armor. The crew would die before registering the impact. Yet crews attempted the maneuver repeatedly. Combat reports documented ON's verified Tiger baiting incidents by January 25. Army Technical Report T-47 sur 44 analysed each incident. None resulted in Hellcat loss. All successfully delayed Tiger advances. Displacement of German tactical doctrine through high-speed maneuver, confirmed effective. Risk: catastrophic vehicle loss and crew casualties. Benefit: disruption of enemy advance timetables and reduction of effective combat radius. The technique spread through Hellcat battalions, despite official discouragement. Tank Destroyer Command. Doctrine forbade unnecessary exposure to enemy heavy armor. Crews ignored the prohibition. They recognized the tactical advantage. A successful bait prevented a tiger from reaching its intended target. One baiting maneuver equaled one critical road junction or supply dump saved from destruction. A crew that successfully baited 2 tigers per sortie prevented breakthrough at 2 separate locations. 2 strategic points secured permission instead of 1. Additional intelligence gathered on tiger unit strength and disposition. The baiting technique created an unexpected psychological dynamic. Crews competed for baiting records alongside gun kill tallies. Battalion boards listed both statistics. Lieutenant James Harrison, 11 gun kills, 8 confirmed baits. Sergeant William Taylor, 9 gun kills, 3 confirmed baits. The numbers became markers of skill and daring. Who could maneuver closest? Who could maintain contact longest? Who could draw the most tigers from their planned routes? Army technical staff recognized the broader implication. For the first time in armored warfare history, lighter vehicles were defeating heavier weapons without firing shots. Human judgment and skill outperformed mechanical advantage. A tank followed its doctrine. A Hellcat crew adapted. The Tiger's tactical rigidity could not anticipate unconventional counters. American crews proved assumptions wrong. German commanders had assumed battlefield superiority meant armor protection and gun caliber. American crews demonstrated the opposite. The first clash between heavy armor and extreme mobility found an answer where the trigger stayed cold. Precision defeated mass. Improvisation defeated doctrine. A Hellcat commander's route selection became a weapon as effective as cannon fire and far more elegant. Firepower and protection mattered, but creativity mattered more. February through March 1944, Detroit, Flint, and Buffalo production facilities. Buick's manufacturing board showed Hellcat output climbing from 40 vehicles per month in December to 120 per month by February. The War Production Board allocated additional factory space, machine tools, and skilled labor. Continental expanded engine production lines. General Steel increased gun output. The supply chain mobilized at industrial scale. Total Hellcat production from program start through VE Day, 507 vehicles. Of these, 512 reached operational battalions before the Tiger threat effectively diminished in April 1944. The remainder equipped units supporting the final push into Germany, pursuing retreating German forces and engaging second-line armor. But during the critical winter months, every additional Hellcat multiplied defensive effectiveness. Tank destroyer command data showed clear correlation. When 25 Hellcats defended the Ardennes in mid-December, interception rates measured 9%. By late January, with 95 Hellcats operational, interception rates reached 63%. By mid-February, with 180 Hellcats deployed, rates peaked at 74%. The relationship was not linear. Doubling Hellcat numbers more than doubled interception success because coverage overlapped. Multiple vehicles could engage single Tigers. Backup interceptors deployed if the first engagement failed. Patrol sectors shrank, reducing reaction time. Integration with artillery created compound effectiveness. The Army coordinated Operation Cobra with General Eddy's 2th Corps artillery. Howitzer batteries lined likely approach routes. Hellcats patrolled secondary corridors. Anti-tank ditches and minefields protected critical points. Each system had defined engagement zones. Artillery fired from TRA 000 to WIT 000 yards. Hellcats operated from Huitcent to DO 000 yards. Mines and obstacles covered key choke points. The architecture prevented fratricide. Artillery wouldn't endanger Hellcats. Hellcats wouldn't enter impact zones. Obstacles protected whatever penetrated both. Anti-tank technology evolved parallel to Hellcat tactics. In December, artillery used standard high-explosive rounds against Tigers with minimal effect. Accuracy against moving targets remained poor. Hit probability approximately 4%. Each battery fired hundreds of rounds to immobilize one Tiger. By January, heat, high-explosive anti-tank, shells entered service. These rounds used shaped charges that focused explosive energy into a superheated plasma jet, capable of penetrating armor. Hit probability remained 4%, but penetration probability increased to 25% on successful hits. Rounds per kill dropped from 250 to 60 pouces the best batteries. General Eddy's February report noted, batteries equipped with heat rounds and improved forward observation achieved kill rates comparable to direct-fire weapons. Best batteries destroy 1 Tiger for every 60 rounds fired. This statistic created operational redundancy. If Hellcats missed, artillery caught. If artillery missed, Hellcats intercepted. If both missed, obstacles delayed. Layered defense reduced penetration probability to near zero for optimally defended approaches. Army Historical Section records documented campaign scale. Germany deployed approximately 500 Tiger tanks against Allied force between September 1943 and May 1945. Of these, approximately 450 specifically targeted the Ardennes sector during the winter offensive. Launch sites included assembly areas near Malmedy, mechanized approach routes through Stavelot, and late campaign pushes through Luxembourg. Of 450 deployed, approximately 340 were destroyed by all means combined. Hellcats accounted for 187 kills. Artillery accounted for 82 kills. Mines, obstacles and aircraft accounted for 43 kills. Remaining kills credited to other tank destroyers, infantry weapons, mechanical breakdown, and fuel exhaustion. The numbers created a grim calculus. St. D Tigers penetrated defense belts. Many bogged down in mud, producing minimal damage. Others reached secondary targets, causing localized destruction. Total American casualties: 142 killed, 891 injured. Total ammunition expended: approximately 160,000 rounds of all types. Roughly 1/8 the expenditure during the entire Normandy campaign, but the Tiger offensive lasted white weeks compared to Normandy's white month duration. Sustained armor attacks became routine. Sirens sounded hourly. Troops fortified positions constantly. Life continued under mechanized assault. Hellcat battalions bore the heaviest operational burden. 602 Destroyer Battalion logged 800 sorties between December and March. 603 Bataillon 200 sorties, 75 Bataillon 900 sorties. Combined, the 3 primary anti-Tiger Hellcat battalions operated 900 sorties in 3 months, roughly 10 sorties per day. Each sortie lasted approximately 90 minutes. Total operational hours: 14,850. 14,850 hours of maximum performance driving. Crews aged years in weeks. Battalion casualties remained surprisingly low. 23 Hellcat crews killed in action during Operation Cobra. Most died in direct engagement with Tigers, route miscalculations that exposed them to frontal fire, or mechanical failures during high-speed maneuvers. Combat loss to German infantry action: minimal. The Tiger operated with limited infantry support. The primary threat came from the tank itself engaging too directly, triggering an 48 mm response, or being caught in a crossfire. Statistical analysis revealed productivity metrics. Average kills per Hellcat crew: 2 Tigers. Top scorer: Captain Michael Reynolds, credited with 28 confirmed Tiger kills. Reynolds commanded the 6th Dungstrossarde Company, specializing in flank attack techniques. His tally represented approximately 8% of all Hellcat-credited Tiger kills achieved by a single crew. His technique emphasized ammunition conservation, average 5 rounds per kill, and aggressive flanking when terrain permitted. In one 5-day period in early February, the 6th Tank Destroyer Battalion destroyed more Tigers than the entire 12th Corps artillery. 34 Tigers, eliminated by Hellcats. 28, eliminated by all artillery batteries combined. The comparison demonstrated Hellcat's superiority when conditions favored interception. Clear weather. Effective forward observation, adequate fuel, serviceable vehicles, and experienced crews. By February, the campaign's momentum shifted. Allied forces stabilized the front lines. Tiger production continued, but deployment rates decreased. Germany adapted, shifting to defensive operations and local counterattacks instead of broad offensives. But these methods proved less effective. Defensive Tigers sacrificed mobility advantage, becoming static pillboxes. Counter-attacking units lacked the concentrated strength of the initial offensive. The Hellcats' role evolved. Battalions transitioned from pure defensive patrols to offensive operations. Crews hunted retreating Tigers before they established new defensive positions. They attacked assembly areas in Germany. They supported infantry advances over the Rhine. The vehicle built to defeat Tigers now pursued them. Speed that had saved Belgium now threatened Berlin. The last great American tank destroyers prepared for their final missions. February 1944, Eastern Belgium and Western Germany. A map at First Army headquarters showed shifting blue pins, Tiger defensive positions throughout the Eifel Mountains overrun by Allied force advancing from Belgium. New threat indicators appeared in rear areas. Divisional repair depot working day and night to return damaged Tigers to service. Germany had adapted. If frontline Tigers faced destruction, repaired vehicles provided second-line resistance. The Wehrmacht's 6th Heavy Tank Battalion specialized in recovery operations. Their maintenance companies carried specialized tools and spare parts. A damaged Tiger, if recovered from the battlefield, could be returned to service within 72 hours if the damage was moderate. The repair battalion worked under camouflage nets, often within artillery range of advancing Allied forces. This tactic created new engagement challenges. Tigers destroyed in forward positions followed predictable distribution. Forward observers tracked them from first contact. Radio operators vectored Hellcats with confidence. Repaired Tigers appeared suddenly from concealed positions, often from directions unexpected by advancing American forces. Controllers had minutes to scramble interceptors. By the time Hellcats reached deployment areas, the Tiger had often engaged multiple Sherman columns. Hellcat battalions adapted. They began operating in hunter-killer teams, 2 Hellcats working together to locate and destroy Tigers before they reached American armor concentrations. Crews navigated using aerial photographs and prisoner intelligence, dead reckoning through forests and villages. Fuel endurance remained the constraint. A patrol extending 30 miles beyond friendly lines consumed 20 miles outbound, 20 miles on station, 20 miles return. Minimal reserve. Mechanical failure meant abandonment. Recovery probability behind German lines approximately 10% before capture. Yet crews volunteered. The logic was simple. Intercept the Tigers before they reached Sherman columns, and no American tanks were lost. 1 Tiger destroyed prevented 6 Shermans destroyed. Each Tiger could engage multiple American vehicles per day. Tank, destroyer command authorized offensive hunter-killer operations. Hellcats became proactive predators. Battalion records documented results. Between February and April 1944, Hellcats destroyed 92 repaired Tigers across the German border region. Some engaged before the Tiger reached operational status, preventing deployment entirely. Others caught Tigers in transit between repair depots and assembly areas, eliminating future threats. The tactic reversed traditional armor doctrine. Instead of waiting for heavy tanks to arrive, Hellcats hunted them during vulnerable transit phases. Repaired Tigers totaled approximately 120 through early 1945, lower than new production, but operationally significant. Americans who had seen conventional Tiger attacks decrease suddenly faced renewed engagements from rebuilt vehicles. Intelligence resources were redirected toward maintenance facility identification. Army summary reports noted hunter-killer patrols extended across German territory, instances of repair facility interdiction recorded. The language remained clinical. Behind it lay extraordinary risk. Crews operated alone in hostile territory. No support if mechanical failure occurred beyond friendly lines. No artillery coverage. No air support in poor weather. Just fuel gauge, map, and determination. For the first time, American armor proactively hunted German heavy tanks before they reached combat deployment. Preemptive interdiction, offensive defense. The Hellcat's mission expanded from reactive interception to proactive destruction. Crews who had engaged Tigers now stalked their assembly points. Speed enabled both roles. The same vehicle that outflanked 56-ton behemoths also penetrated German rear areas undetected. The campaign that began as defensive desperation evolved into offensive dominance. America no longer merely stopped Tigers. America attacked the system that deployed them: assembly areas, repair facilities, supply convoys, fuel depots. The Hellcat became a symbol of adaptation, a vehicle flexible enough to evolve with changing threats. Speed alone did not guarantee success. Applied intelligence, knowing when and where to use speed, determined outcomes. February 1944 marked the inflection point. Germany deployed, but America controlled. The Tiger remained a threat, but no longer an unstoppable one. Industrial production, tactical innovation, and crew skill combined to create systematic defeat of Germany's premier tank. The word premier implied superiority. By February, it meant only desperation. February 15, 1944. 1st Army Headquarters, Belgium. Operational Research Section analysts pinned a new chart to the briefing room wall. 2 lines crossed. Blue line, Tiger survival probability. Red line, interception effectiveness. The crossing point occurred at 6 hours on February 14. For the first time since the campaign began, more Tigers were destroyed than reached objectives. The numbers told the story. December 20, 9% interception rate. January 15, 41%. February 11, 63%. February 14, 74%. The curve was exponential, not linear. Each additional Hellcat, each improved tactic, each upgraded artillery battery multiplied effectiveness geometrically. Systems integration produced results that exceeded the sum of individual components. Operational Research Section Report 10 Accept sur 44 summarized findings. Probability of target achievement reduced from 0, 80 tons to 0. 26 for principal approach corridors. Integration of high-speed tank destroyers, HAT-equipped artillery, and improved forward observation created a multiplicative defensive advantage. Each system compensates for others' weaknesses. Redundancy ensure mission success despite individual component failures. The report quantified contributions. Hellcats, 55% of kills. Artillery, 24%. Mines, obstacles, and aircraft, 13%. Mechanical failures and route errors, 8%. The distribution showed balanced defense. No single system dominated. Each provided essential coverage. Hellcats caught Tigers in open terrain. Artillery protected prepared positions. Obstacles defended urban approaches. Failures occurred when vehicles broke down or got lost. Hellcat effectiveness correlated directly with vehicle numbers. 5 additional Hellcats increased the interception rate by an 5%. 10 additional Hellcats, 4% increase. 20 additional Hellcats, 10% increase. The nonlinear relationship derived from patrol coverage geometry. More vehicles meant smaller sectors, faster response times, multiple engagement opportunities, and backup interceptors if initial attacks failed. Artillery performance improved dramatically with heat-round deployment. December average, 250 rounds per Tiger immobilisation. February average, 60 rounds per kill in best batteries. Some elite units achieved 1 Tiger per 70 rounds, comparable to Hellcat ammunition efficiency. General Eddy's technical staff credited 3 factors: shaped charge projectiles, improving penetration probability, improved forward observation accounting for Tiger movement patterns, and crew training emphasizing rapid-fire missions. The statistical breakthrough created operational confidence. Controllers deployed Hellcats knowing interception probability exceeded 70%. Artillery fired knowing penetration probability approached 25% on hits. Infantry planned knowing Tiger penetration probability was below 30%. Advancing troops fought knowing most Tigers would be destroyed before reaching their positions. Psychological impact mattered as much as physical results. By mid-February, 450 Tigers had been deployed toward Allied lines in the Ardennes. 340 were destroyed by all means. Saint-D reached operational objectives, mostly fortified positions or secondary road junctions. Critical targets, supply dumps, command centers, major bridges experienced decreasing attack frequency. December. 12 critical targets engaged per week. February. 2. 5 critical targets engaged per week. The reduction saved thousands of lives. Germany recognized failure. Tiger production continued, but strategic utility declined. If 74% were destroyed, deploying Saint Tigers delivered only 26 to objective areas. Cost-benefit analysis favored defensive operations or local counterattacks, but Hitler demanded continued offensive operations. Propaganda value outweighed military effectiveness. Vengeance operations justified continued sacrifice. German crews died operating tanks that achieved negligible results. American intelligence monitored German reactions through intercepted communications. Wehrmacht reports described unacceptable attrition rates and systematic interception. Mock staff papers questioned resource allocation. Why build Tigers when simpler tanks delivered more tactical utility with lower loss rates? The answer was political, not military. Hitler believed heavy armor would reverse Germany's strategic position. Reality proved otherwise. The operational research section's closing assessment stated, "Human adaptability exceeded mechanical design capability. Automated doctrine follows fixed patterns. Human operators adapt to circumstances. American defenders innovated tactics baiting, hunter-killer teams, integrated systems that defeated German engineering assumptions. Probability of success inversely proportional to doctrinal rigidity. The more rigid the tactical doctrine, the more vulnerable to creative countermeasures." This conclusion influenced post-war military doctrine. Heavy tanks required flexible tactics for effectiveness. Pure armor protection created exploitable vulnerabilities. The lesson echoed through decades. Technology multiplied human capability, but could not replace human judgment. The Tiger campaign proved that principle at scale. Germany bet on armored superiority. America responded with tactical ingenuity. The outcome was never in doubt once America mobilized its industrial and intellectual resources. With the Ardennes threat largely neutralized, the campaign's center of gravity shifted. The Rhine crossings became Germany's new defensive priority. Tigers protected key bridges, but the defensive system followed. Hellcats redeployed. Artillery moved. Forward observation expanded. The pattern repeated. Initial shock, rapid adaptation, systematic defeat. Germany defended, America advanced. The balance favored attackers increasingly. April 12, 1945, Northern Germany and Baltic coast. A German maintenance crew recorded one of the final Tiger repairs near Rostock. The repair battalion had operated since September 1943. 20 months of continuous recovery operations. Hundreds of tanks were salvaged. Negligible strategic impact. Allied forces approached from west and east. Defeat was imminent. yet orders demanded continued operations. The last repaired Tiger rolled from its maintenance bay, refueled, rearmed, heading toward Leipzig. The vehicle would stall 20 miles later. Transmission failure or fuel exhaustion. American plotting stations tracked the movement. Controllers noted the trajectory. No interception necessary. No Allied advance was threatened. The war's first true heavy tank campaign ended not with drama, but with irrelevance. Campaign statistics compiled by April 1945 showed the full scale. Germany produced approximately 500 Tiger tanks between 1942 and 1945. 100 deployed against Allied forces in all theatres. Of these, 840 were destroyed in combat. 342 Americans were killed engaging Tigers, except 891 injured. 500 rounds of ammunition were expended. Less than a week's production from American artillery factories. Hellcats accounted for 278 Tiger kills across all theatres. 187 poussent the Ardennes sector. 67% of all Hellcat credits. Sherman tanks, 190 kills. Artillery, 195 kills. Mines, aircraft and mechanical failure, 177 kills. The Hellcat dominance reflected speed advantage and crew proficiency. Top individual score. Captain Michael Reynolds finished with 28 confirmed Tiger kills. The battalion average, 2 kills per. Hellcat crew over the campaign duration. Anti-tank artillery destroyed 195 Tigers. Mines and obstacles accounted for 21. Mechanical failures, route errors, and fuel exhaustion accounted for the remainder. The integrated defense system achieved its objective, reducing strategic impact below acceptable thresholds. Germany's premier tank became a tactical nuisance. American casualties, while tragic, remained far below German predictions. Initial intelligence estimates suggested 20,000 deaths if interception rates stayed below 20%. Actual toll, 342, roughly 15% of predicted loss. The difference, 74% interception rate achieved by February 1944. Every percentage point of interception effectiveness saved dozens of lives. Mathematics translated directly into survival. Hellcat battalions transitioned to new missions as Tiger threats declined. They supported Rhine crossings. They pursued retreating German forces. They engaged second-line armour in the war's final battles. The vehicle designed to outmaneuver Tigers now hunted conventional tanks during Germany's collapse. Speed remained the common thread. Hellcats could not match Tiger protection, but could exploit Tiger's limited mobility and fuel constraints. Continue battalion casualties totaled 39 Hellcat crews killed in action. 23 died during Operation Cobra. 6 died in pursuit operations across Germany. Loss rate approximately 0.4% per sortie, remarkably low for intensive combat operations. The Hellcat's speed provided a survival advantage. Fast vehicles presented difficult targets. Crews who could accelerate away from danger lived longer than those operating slower types. Post-war analysis credited the Hellcat with decisive contribution to Tiger defeat. Army summary stated, "The M18 Hellcat's speed and handling qualities enabled interception tactics impossible with other vehicle types. Integration with forward observation and artillery created systematic defense against heavy armor. Lessons learned inform future. Tank destroyer doctrine." American Heritage placed a commemorative marker at Clairvaux, site of the first Tiger Hellcat engagement. The inscription reads, "Here America's fastest tank destroyer first engaged Germany's heaviest tank, December 1943. This weapon and others like it were defeated by the courage of American crews and the skill of tank destroyer battalions. Their sacrifice preserved this ground." The marker mentions no specific vehicle types, yet Hellcat crews knew they had driven the missions. They had intercepted the Tigers. They had baited 4.28 secondes and fired 76 mm rounds. They had won. The campaign's conclusion carried historical weight. For the first time, an extreme mobility vehicle system faced systematic victory against extreme protection vehicles. The pattern would repeat throughout history. Heavy threats emerge, mobility adapts, technology evolves, speed prevails. The Tiger campaign established that pattern. Germany believed armor guaranteed success. America proved tactical ingenuity countered armor. The lesson transcended the specific conflict. It defined mechanized warfare's future trajectory. The first purpose-built American tank destroyer had defeated the premier German heavy tank. Speed, precision, and adaptability overcame armored superiority. Human crews outthought mechanical advantage. The margin was narrow 74%, not cent%, but sufficient. Victory required sustained effort, industrial mobilization, tactical innovation, and individual courage. The Hellcat provided the platform, crews provided the skill, America provided the will. Together, they wrote history. May through August 1945. Buick Works, Detroit, and Army reports. Engineering drawings annotated with torsion bar suspension were archived in the company's technical library. The M18 Hellcat's development had solved a critical problem. Mobility at high speed. Test driver files contained performance data that would influence vehicle design for decades. Maximum speed 55 miles par heure. Cross-country, speed 42 miles par heure. Control response is positive and predictable throughout the envelope. These characteristics became benchmarks. Post-war evaluation memos analyzed what made the Hellcat exceptional. The lightweight torsion bar suspension reduced weight by 22% compared to conventional spring systems. Weight-to-horsepower ratio 14. 5 HP, ton dramatically better than the Sherman's Dix. 8 HP ton. Lighter weight created better acceleration and cross-country mobility, but required careful structural engineering to maintain durability. Buick's designers succeeded where others failed. The chassis carried a 76 mm gun, ammunition, fuel, and crew protection, while remaining light enough to reach 55 miles par heure on roads. The open turret represented a critical innovation. Traditional tank turrets protected crew but added substantial weight. At high speed, every pound decreased performance. Open turrets solved this elegantly. They reduced weight while maintaining visibility. Crews gained 360-degree observation. They identified threats instantly. They engaged without turret rotation. These characteristics proved decisive against Tigers. The engineering philosophy could be summarized simply: don't get hit. The Hellcat wasn't designed to survive direct hits. It was designed to avoid receiving them altogether. This characteristic proved decisive not just against Tigers, but in all mobile operations. Crews who operated Hellcats and later transitioned to conventional tanks noted the differences. The M18 Pershing, America's late-war heavy tank, incorporated suspension design philosophy from the Hellcat. The M18 Jackson, an improved tank destroyer, used refined Hellcat mobility principles. Even the M18 Easy 8 Sherman benefited from lessons learned. The Hellcat's legacy lived in suspension design across multiple vehicle types. Ardennes Proving Ground Analysis stated, "The M18 Hellcat's cross-country performance and control response remain the benchmark for tank destroyer types. Future designs should prioritize mobility equally with protection. Armor without maneuver creates vehicles that engineers admire, but combat crews cannot effectively employ." The design lineage was clear: M18 Wolverine to Hellcat to M18. Jackson represented evolutionary refinement. Each generation improved upon predecessors, but the Hellcat occupied a unique position. It arrived at precisely the right moment to face an unprecedented threat. Earlier delivery would have missed the Tiger campaign. Later delivery would have found the campaign concluded. Historical timing mattered as much as engineering excellence. Production totals reflected wartime priorities. 570 Hellcats built through VA modest compared to Sherman production. 49,000 plus, or Soviet T-34 production 80,000 plus. But the Hellcat served a specific role exceptionally well. Not a general-purpose tank, not a breakthrough vehicle, a specialized interceptor optimized for mobility and accuracy. The mission defined the machine. The machine fulfilled the mission perfectly. Captain Michael Reynolds, credited with 28 Tiger kills plus numerous pursuit successes, summarized the vehicle's contribution. The Hellcat proved that speed combined with precise control creates combat effectiveness exponentially greater than armor alone. Every crew who operated it understood this immediately. The war taught us many lessons. The Hellcat taught us that mobility makes protection useless. That lesson informed Cold War armored doctrine. Mobile anti-tank units guided by forward observers became standard. The pattern established in winter 1943 à 44 observations, vector, interception repeated in systems defending against Warsaw Pact armor. The specific technology evolved, the operational concept remained. The Hellcat campaign created the template. The fastest American armored vehicle left its mark not only in kill tallies, but in design philosophy copied into post-war projects. Speed mattered, control mattered more. Hellcats moved fast, but they moved controllably fast. That distinction defined excellence. That distinction saved Belgium and Luxembourg, July 1945 through 1946. Army Historical Section compiled final campaign statistics. The numbers documented both German ambition and American response. Tiger production, approximately 5 cents units. Deployed toward Allied targets, 100. Destroyed in combat, 840. Reached objectives, 260. Direct hits on strategic targets, fewer than cent. Strategic impact, negligible. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.